All right, so this week you guys should see chapter 11, which is debugging. This is going to be an important chapter as this is going to be part of your final project requirements. So I'm going to show you the debugging portion, and then I'm going to show you what you need to know for the final project. So make sure you guys will reference this video for that. Let's see, for that, what I'm going to do is today we'll go through debugging, and then on Wednesday we're going to go through the portion that's actually for the final project. In other words, I'll recap what you need to see in your final project. You also have a quiz this week, as it's highlighted here. Make sure you're paying attention to the type of question. In other words, is it multiple choice or multiple answer, true, false, etc. And I think that's about it. So let's get into chapter 11. So up to this point, you've been working with Python, and when you get an error, you get a pop-up, that comes up on the command line that tells you you have a type error or you have a file not found, whatever it shows up within that idle prompt, you get an idea of what's going on there. And so far, we've used try and except anytime that we have a potential for a failure. And on that except, we could accept on a particular type of error exclusively, or we could do it on any error. What we're going to talk about today is one called raising exceptions. And the idea behind raising this exception is anytime it tries to execute invalid code, you get an exception. And you guys have seen something like this right now, where you've seen something like this on the output. Now, what we're able to do is write our own exceptions within our own code. So if we want to raise an exception that would cause the program to stop, we can do that. What we can do here with the raise exceptions is we can use the raise keyword, and then we do a call to the exception function, just like you see here. So we use raise and then exception, and then we pass whatever error message we want into here. And it's whatever's relevant, helpful error message that we can pass to our end user. When that happens, our code will spit out something like this. So this is already built into Python. We already get these type of exceptions already. You have the ability to write your own exceptions depending on what your code is. And then maybe you could accept or try and accept on those own individual exceptions if you would like to. So as you can see here in this particular piece of code, we can raise an exception if we want, if it doesn't meet this particular if statement. Same way with all these other ones, we can print that out. And the moment it hits that, we can use a try and except. We can do exception as error, which means we're just grabbing whatever that exception is, and then we can print that out. So we can print it out in a nice clean string so that we can let the user know what's going on without just showing the red text or whatever's coming out at the prompt. Anybody have any questions over raising exceptions? This part will not be on the final project, but you have the ability to raise exceptions if you would like. All right. The next piece that we're going to talk about is tracebacks. So as you guys have seen within some of your exceptions, and when the error comes back, we have the ability to do a little bit of error information, and that's called a traceback. So we can set up this kind of information. And the idea is that if we import traceback and then try to raise an exception and then accept on whatever we want to, what this will do is allow us to get some more traceback information. We can kind of write our own. So again, you already see this kind of stuff today. When you make an error in Python, it gives you an error. We're allowing you to create your own errors, so to speak, so that you can let the user know something for your code. Again, this particular portion is not necessarily on the final project, but I do need to make you aware of it. This last one here that we're going to talk about in this debugging side is going to be assertions. So an assertion is basically a sanity check, and it's used to check your code to make sure something obviously isn't wrong. And these sanity checks are performed by using this assert statement, an assert keyword. And if that sanity check fails, then the assertion error is raised. And in that code, we can assert that and bring in the following. So for example, if we have this ages list here with all these different integers, we can sort these by using the dot sort. We can then see what ages looks like after it's been sorted. And then if we run the assert statement, we can check to see if ages 0 is less than or equal to ages -1, which means this needs to be less than or equal to this. If for some reason that failed, then we would get the assertion statement. We'd get a traceback. In this case, this is going to pass, right? 15 is less than or greater than 92. However, if we do a reverse or, you know, a reverse sort, now all of a sudden 73 is going to be at the front, and we're going to see 26 down here at the end. We're going to see that this fails. Then at that point, we get a traceback with an assertion error, and we could handle better errors if we so chose to do so. So again, assertion is kind of like a traffic light where they take you through this little simulation. But the idea is that you can test your code within your script, and then you can assert whether or not it's actually working or not and raise errors if you need it to raise errors. This is going to be a little bit more advanced in what you're going to need in this particular course, but I have to introduce it to you so that you are aware of it if you go into further scripting, or maybe you actually start writing more Python programs in the future. All right. This is the piece that you guys will need to know the most when it comes to your final project. So when your final project, you guys will need to have logging. And what logging does is, more than likely, as you guys are working through your code here, you're probably using the print statement to print out some variable or something like that, so you know what that variable is at this point in your code. And it's a great troubleshooting tool. It's a great way to debug your code and find out what something is along the way. The problem is that you then have to go back and make sure that you remove all of those print statements at the end of your program. Otherwise, you know, you're going to get a bunch of output on your screen that you wouldn't intend for anybody to see. So what we have is the ability to use the logging module. And so with the logging module, what we can do is we can output text to either the screen or to a text file, and it's treated like a log. So instead of printing it out to the screen, et cetera, and that kind of piece, we can output those variable informations. We can put out our own text. We can put out whatever we want, but it doesn't affect the program, unlike a print statement, which is going to actually print it on the screen, and it could affect the program. So for your final project, if you'll remember in your midterm project, I told you needed to have lots of comments throughout your project. And that was a big chunk of your score in your midterm, was making sure that you were very heavy on your comments and explained what was going on during that code. Part of that is so that I can see what you're doing within your code. But the other part of that is because when you now implement this logging module, you can take that information that you used in the comments and display that out in a logging configuration. So you will be required to import logging. You'll have to set up the basic logging configuration, and then you'll need to have a couple different logging statements within your code. And you can use a little or a lot, but you need to at least have one. Let's see, we'll go through those requirements inside of there. So what you're seeing within this import logging, you import the logging module. And then after the logging module, you need to have this basic configuration. Now, for your final project, I'm going to just temporarily scroll ahead here, and we'll come back and talk about that other stuff. This is the one that I want you to use for your final project, where it actually logs it out to a file. And the reason I want it out to a file as opposed to just printing it on the screen is the printing on the screen will affect or detract away from your project. I don't want you to do that. I want you to just literally copy and paste this into the top of your project. So we'll cover that a little bit more when I go over the final project requirements and things like that. But you want to remember this section here, logging to file. It's a matter of taking this, copy and pasting it in. Note, when you're actually working with this side of it and you're pasting this in, when I paste this in, notice that it's all kind of cut off. And the reason is when you copy and paste from the web, that actually is set up to be a new line here. So you have to backspace and bring that over to the next section here. Then if you would for me, go ahead and just bring this down to the same line. So remember in Python, when it does a comma separated, when you're passing values in, you can hit enter and align them cleanly. If you do this for me, then it actually fits on the screen without having us both scroll over off to the far side. You can change this file name. You can adjust it, whatever you want. It does not matter for the purposes of your project. I just need to have this in your project. Okay. Now, when we talk about logging, there's different logging levels. And you guys may have heard the words debug before and things like that when you're dealing with programming, or maybe you've used some programs in the past that has the word debug. The way debug works is it's just a logging level, and it's the very lowest logging level, or in some cases, it can be considered the highest level, depending on how you're looking at it. For the purposes of Python, debug is the lowest level in this chart. Now, this is where a lot of people mess this up because it's first in the list. They think it's the highest level. It is the lowest level when it comes to doing that. When you're talking about programming, low level means that you're getting all the details. You're getting every message, you're getting every diagnosing. You are at the lowest level of everything in there. The critical is going to be the highest level, which means you're only going to get very specific messages. So if I set my logging level to error, then in error, I'm only going to see critical and error. It's only from this point and higher. If I set it to debug, then I'm going to get all of these type of logging messages that may be inside of my code. Again, the way this is set up here, people get this flip-flop, so pay attention to the logging levels. If I set my program to be at critical logging level, then that means I'm only going to get the highest level log messages. I will not get the minute details. As a matter of fact, logging.critical, I should only see it when that program is about to crash, as you can read over here. So a fatal error has occurred and the program is about to crash. This is one of the required levels that you have to have in your program. And I get this a lot. They're like, well, the students go, well, you know what, my program isn't going to crash. I wrote good code. That's my point. You need to find a way where your program can crash, and you need to put in a logging.critical. So when you use these logging messages within your final project, they need to be used appropriately and correctly. So logging.debug, you may use this to output input that somebody might have typed in. So for example, if you ask for a user's name and you bring in their name, you could take whatever they typed in and put it into a debug log so that when we're looking through your logs as our chronological order of your program executing, we can see what the user typed in, where right now you guys are probably using a print statement in order to see what the user typed in or what that value may be after you do some changing or manipulation, etc. If we do it out to a log file, then if you guys have ever troubleshot any other software that's ever been out there, they usually have log files, and that allows us to go back and see what happened from the start of the program to the end of the program, whether that's just basic debug information or whether that is high-level logging all the way through. So for your final project, you will need to have debug statements and you will need to have critical statements. You can use any of these other ones inside of that. That's perfectly fine, but you must have one debug and you must have one critical. Okay. And again, on Wednesday, we'll cover this in a little more detail as to what that looks like when you put that in. This is worth a good chunk of points on your final project. It's very simple to do. You are just copying, pasting this portion of the logging to a file right here. Just like I showed you, you copy this into your program like this, and then you need to have one logging.debug and one logging.critical statement. You could have a lot more than that, and I encourage you to do more than that, but you need to at least have one of each of those. So again, what are these logging levels and why would we use them? Logging.debug is where you want to print the output and the variables like I just told you before. A logging.critical means that whatever they typed in, or if your program is about to crash, then you would use a logging.critical. If whatever they typed in has a problem or it could cause a problem, then maybe you want to use a lower level, like maybe say a warning or an error. A warning means that it's a potential problem, but it's not going to crash the program. It's not imminent failure at that point. Error means that you're probably going to cause the program to fail to do something, with critical meaning the program's going to flat stop more than likely. So read through this table, understand this table. Hint, hint, there will be questions on the quiz about this. And then for your final project, make sure that you're using these correctly. Anybody have any questions over logging? Again, logging is, you can treat it just like you would a print statement. When it outputs to the log file, you're going to see something like this. Now, if we look at this particular statement that I had you copy and paste in, you'll see that we are going to a logging file. We're going to set our logging.debug. So we're always wanting us to be the lowest level when I want your debug output. And then the format is how you will end up logging this to the file. So right here, by default, it's going to take the time, it's going to take a level, and it's going to take a message. If we look at the output of something like that, it will look like this. So you have a timestamp all the way through, you have a dash to the log level, and then you have a dash and then whatever message you wanted it to print. When you use this, in order to use a logging statement, you will import logging, set up that basic config, and then as you see here, you can do one of these at the beginning, like a logging.debug, start a program. This means at the very top of your log file, it's going to say start of the program. And then as your program executes, it's going to log each one of these logging statements down. So logging.debug is going to set a debug level. Logging. If we used any of the other levels, for example, error or warning or critical, then they're going to show up as a different error type. So inside of here, you can see each one of these came up as debugs because they're using the logging.debug statement. All they're doing is just passing whatever string you want in here. So you can use this format. You can treat it just like a print statement. Again, the idea being that you can then debug your program and find out a little more of what's going on. If you use logging.criticals, you're going to see statements like this. If you use errors, you're going to see logging.error statements. It does talk about disabling logging. What you would do here is if for some point in your program you want to turn off the debugging, you don't want to use it, you just pass logging.disable, and you can disable whatever level you want to do. Notice that once you do that, you have to restart it in order to bring that back. It'll suppress all messages. So you don't have to worry about this part for the final project, but just so you're aware, if you pass a logging.disable, it will end up disabling all messages after that. Does anybody have any questions over logging? Okay, there should be a question, and that question is, well, how do I use logging.critical? Right? Debug's easy. You can use debug just to print out any information, but a critical means that that program is going to crash. That doesn't mean that you use it at the end of your program, because your program isn't crashing, your program is ending. So the only time that you would more than likely see a logging.critical is any time that you are going to import something. So for example, I want this at the top of my code right off the bat. This should be, I've got my initial 3 comments. I've got my explanation of what my program is or what my final project is. Tell me what that is. And then you also need to tell me in here when we start talking about OOP, and I'll cover this a little more on Wednesday, you need to tell me how to install any additional packages. So if I need to install play sound, you'll give me those commands. You'll need to give me anything else. If you are using any third-party packages outside of what's built into Python, so if I have to do a pip install in order to execute your code, you need to give me those commands upside in your comments here. From there, you want this import logging first, and then let's say I want to install play sound, or I need to use play sound for whatever reason inside my code. If I just do a import play sound and I don't have that play sound package installed, my program's going to crash. That would be points off on your project. Your program should never crash. What it should do though is tell me that I need to run this command. So to do that, we can use a try statement, and we can try to import play sound. If that fails on an exception, then in our except statement, we would say something like logging.critical, please run pip install play sound. Something like this. We're going to do this in single quotes because we use doubles there. The program will now exit. Okay, and then at that point, we will want to tell that to the user. Now, what this logging.critical is going to do is it's going to put it in the log file, but we're not really telling the user what happened. Why is my program ending? So you'll still want a print statement in this case to go out to the user, and we can just copy and paste the same thing. That's fine. And then now we need to use something like sys.exit to cleanly end the program. We don't want the code to continue because without this package installed, the program's going to crash, right? So we need to have sys.exit. In order to use sys.exit, we need to import sys. So before you're logging, you will need to do something like import sys. Now, if I try to run this program and I don't have PlaySound installed, I'm going to get my logging.critical error go out to my log file. I'm going to get it printed on the screen that says I need to run this command. That way I can copy and paste it on my console and immediately run the command. And then I'm going to cleanly exit my program so that we don't crash the program into a bunch of red text. Now, you could also on this side, when we imported PlaySound, you could use a logging.debug. And in this one, we could say PlaySound module loaded successfully. Okay. This is going to put it in our log file that we imported the PlaySound module, right? And you can change the wording of any one of these however you want. It's your own text message. It doesn't matter. But what this is going to just show us in the log file that this module loaded successfully, and it will continue on down the code. So you can kind of think of it as little markers in your code to let you know at what point maybe your program crashes or at what point you have any issues, or if you just want some debug code so that we can better understand how your program's executing a line at a time. This right here is pretty much going to be all the points you need for your final project. Now, I would like to see for any third-party package that you have this format. If you're not using third-party packages, you still need to find a way to use logging.critical. In that case, the only way to use logging.critical is you need to import something into your project. So say, for example, I had a bunch of different functions over here. So we're just going to call this function 1, and we have some code here. Sorry. Right? And inside your programs, you should have multiple functions within your code, whatever it may be. But as you notice this and you start building out your final project, you guys may have a bunch of different functions and a bunch of different lines of code. So say I have function 1, function 2, whatever it ends up being. The best way to get your logging.critical requirement is going to be go ahead and open up a new file. Go ahead and copy and paste everything that came out of this one for your functions over to this side. Now back over in your main file, we need to import. We'll save this out as say functions.py. Then what I would do is over on this side, I would say import functions. And I don't need the .py when you import another Python file. You just, whatever the name of the file is, as long as it's in the same directory as their main program, it will go ahead and import that into this program. Now, when you do it with import functions, as you guys have learned with modules and stuff, when you import it, you have to call it, right? So for example, I import logging, I have to use a logging dot whatever in order to get the stuff that's in this module. If I import functions, then I would have to come back and do something like functions.function1 in order to call the function that's over here in this piece of code on the right. This is a little cumbersome because I probably wrote my entire project with it just using functions1. So in order to do that properly over here, you would want to do a from import. So from functions, import, and we're going to use star. And what star is going to do is it's the Python equivalent of taking this code that was in this other file and pasting it right back into this file, which means I can call function.1 or function1 directly, just like this inside my code now. It's also a little bit cleaner because I can have my main code run over here, and over on this side, I can have all my functions. There may be reasons that you want to break this up into multiple functions or multiple files. So for example, I may have my functions in this file. if you guys are doing text adventure games and you got long blocks of code or text, you may want to put that text in another file so that you don't have to search through, you know, thousands of lines of code over here to make a change in an error or something. You put it in your paragraphs.py file or your functions.py file. And then you can individually go to those files and edit what needs to be edited and add it on. Another reason that you could use that is if you want to add multiple levels to your project or game, or say you're doing like a text adventure game and you want to add a new level, you could tell it to import the levels function or the levels file that you create over here. And then anytime you want to add a new level to the system, you just create a new Python file with everything it needs to be there for a new level. And you could just import that new level in, right? So say you called that file new level, you could just import new level on this side. Again, you need to wrap these inside of a try and except, because if for some reason that file doesn't exist, the program's going to crash. So when we come back over here to our functions import that we have on this side, let me get this back for a visual cue here. There we go. Instead of just doing from functions import star, we need to do try from functions import star, and then on an exception, we need to have a very similar lines of code like this. So from here, we're not going to do a pip install. What we need to say is missing functions.py, and then it can go through and pull that file out. We would want to copy this same kind of message and tell it to the user that, hey, we're missing a file for our project. And then we would go ahead and end. If it does load successfully, we can use something like this logging statement here. And we could say functions.py loaded successfully. So again, anytime you're importing a third-party module like PlaySound, where you're doing a pip install, or if you've broken your code out to another file, then you need to make sure that you put these in try and accepts. That way, if that file goes missing, your program doesn't crash. This is how you will get your points for logging.critical in your final project. Please pay attention to this video. Please remember this section. This is the part that students trip up on. It's easy points for the final. You just have to do what I'm showing on the screen. Anybody have any questions on that? Again, anywhere in your code down here, say I'm executing something, whatever it is, all I have to do is use a logging.debug if I want to save that information. So say I have something like my name equals input, then I would say logging.debug user typed in, and then we could use like an F string here if we wanted to. So if we did it in an F string format, we'd put an F there. Then inside this, we're going to put my name like that. And then what that's going to do is take whatever they typed in for my name and put it in here. If you want to use the other format that most of you are familiar with at this point, you could do something like this plus my name. That would also work. And what it's going to do is just whatever they typed in, immediately dump it into your log file. Then you can go ahead and continue to do whatever code that you want to do. You execute some more stuff. Maybe you calculate a new age. So for example, if you go back to homework 1 and you had them type in a name or an age, and then you did some math to that name or age, then after you change that, so let's change this to say my age, just to make this understandable. They type in an input. It says user typed in here. Then we can say try, and we're going to say, int my age plus 10. We can say age in 10 years. That's our new variable. And then we can say print this kind of thing. Or if we're just calculating this or doing whatever, the only reason I put this in a try statement is, remember, anytime I'm dealing with converting a string over to an integer, I need to put it in a try statement in case they typed in some random word and not an actual number. It doesn't crash my program. So we could do except. And so normally when you do while state or inputs, you want to do these in a while true. We've talked about this in the past. So that way we can loop them until they do it correctly. So in other words, if we try this and it works, then we can break out of our while loop on an except. We could say something like print that is not valid input. Please try again. And so we're here where we have this error exception in here. We could also put this in our logging file. So we could do a logging dot say warning or logging dot error or whatever level we want that makes sense based on what we see within this table. So in this case, it's probably going to be a warning, right? Because we're not really seeing that it's going to cause a problem. It's not going to necessarily prevent it because we're going to loop back and tell the user that they need to put in something correct. So we could do a logging dot warning and say user did not type in a valid age, prompting user again. And then it's going to go ahead and print out to the user to tell them that's not valid input, try again. And then it's going to start this while loop over again, asking them for their input. So you may say, please type your age, something like that inside our input statement so we can see what's coming on. So this is where you would use like a logging.warning. Here we were able to do this. So we can either do a logging.debug or maybe we use something like logging.info, which is where we're just giving information on this. And in this logging.info, we will say user calculated age is, and we'll just use that same method that you guys seen here. So we'd say plus and then string our age in 10 years. Something like that. And so now in our log file, we would see after we calculated this, it's going to log what that age is. We could go ahead and continue our code, do something with it. If they typed in something wrong, we could use a logging.warning. So this is what I want to kind of see inside your final projects in terms of logging. That's the important part to take away from today, is doing logging correctly in your final project. The rest of this chapter, I'm not going to necessarily cover it, but what it does is show you how to use the debugger functions within Mu. So if you are a programmer, computer science student, et cetera, and you need to want to do some debugging, et cetera, because you're familiar with other coding, then you can go ahead and use this. There's Mu's debugger. You can also use idle's debugger. It will show you that here later on in the code as well. Anybody have any questions over this logging? Again, it's important because it's for your final project. If you don't get it, just say you don't get it because it's not a big deal. You can text it to me here in the chat, whatever. I just want to make sure you guys understand.
Honestly, I don't understand much of what's going on, but I can maybe figure it out a little later.
Once you start going back and adding it in your code, right? So if you look at your code today, you probably had something like here, you're going to be like get user name or user age, right? And you guys have been pretty good about putting comments in your code. Well, because you did this comment here, right before we go into this while true statement, we can do a logging.debug. We just copy in your comment like this, so that now you have a good logging statement knowing what's going on before it executes this piece of the code. You guys are probably already doing this in the process of debugging your stuff, but just using prints. Instead of using prints, use logging.debugs, because then you don't have to go take those out of your code. All the print statements when you forget to remove those extra print statements. So if I go ahead and save this, let's just do something like save example, and then I run this. Notice I don't have play sound installed in this particular case, so I get my nice little error message. My program didn't crash, right? It said, please run pip install. The program's now going to exit. If I didn't have this, so let's comment this out for the time being. And let's do a import play sound. And then I run my program crashes. I lose X amount of points on my final project because my project crashed. So this is the reason we would wrap this inside of a try and except statement. So if I uncomment this again And yes, I will be intentionally trying to break your project, because that's the point, is that you guys built in fail safes within your project. So if I run this again, we're going to see that we hit my accept statement. We're going to see that we get this printed out to the end, in this case here, but I also have a logging file. So if I go look at where this file is saved, let me do this off screen here real quick. So C, users. That's why it's better for you guys to save these in the appropriate place, but let me chase this down here real quick. Okay, when you look at this particular folder, you're going to see our program that we just created, examp here, and we're going to see this my program log.txt. If I open this, you're going to see my critical statements that were coming from my code. Notice that every time I run it, it's going to add to this log file. So if I close this and run this again, okay, I go back and look at my log file, I now have 3 critical statements in there telling me it's crashing. So this way I can always go back and take a look at this log file and see what's going on within my code. So now to fix this error, I would need to go and do my pip install playsound. I'm not going to do that for this particular portion. I'm just going to comment this out. And now it's missing functions.py. Well, I don't have a functions.py, so I'm going to temporarily bleep this code out. All right. So it asks for my age. I'm going to do ASDF. Note that my program crashed here, right? Because the reason it crashed is it takes in this my name, and my name is not defined. Well, that's because I changed it, right? This is now my age. So let's run this again. All right. Oh, I hit the wrong button. There we go. So if I type in this invalid input, I see this part here, but if I were to go open my log file, notice that I'm getting warning statements of what's in here. I'm also getting my debug statement as to what the user typed in when they came in and tried it. If I close this down and I go ahead and go to my code here and I type in 35, nothing happens because our code doesn't do anything. It just breaks. But if I go look at the code here, we're going to see that we get our info statement that the user age was 45. Now, if you have this log file open while your code is executing, it's not going to work well because it doesn't have write permissions to this file if you have it open. So make sure you always have that log file closed. When you guys submit your programs to me, you do not need to include the log file. But if you do, because it's in your folder, that's fine. It's not a big deal. But you do not have to include it, because the next time I run it, I'm going to flush your log file just by simply deleting it. And of course, it's not letting me because I have it open. There we go. If I just delete this log file and I have it again open somewhere else, let's take a look here. Actually, it's logged because it's over here, so I'd have to just close out of it. But if you delete this file and then rerun your program, it's going to start a brand new log file inside of there. So that's why it would be smart to do something like the book showed here, to do a logging.debug start of program. Something like that. And then I would see that in my log file that I got up to this point, and then I can do my logging. If I see my 2 imports went successfully, like this line here and this line here, then I know I'm already past that part in my code. I'm now down here in my user age. Get the user age. Does anybody have any questions on adapting their midterm project using the logging requirements?
It's going to automatically make the text file like for us. Then we don't already need to have one of those logging text files just made and empty.
Yeah, if I heard you correctly, yes, it will automatically create the log file. Yep. So if you delete it, it'll automatically create a new one. If the log file exists, it's just going to keep appending to it automatically. There was somebody else that had a question.
I guess mine was rather specific, but I wonder if would this catch the accidental loop that I have in mind where it, regardless of what you put for the input, it will ask it twice?
It might. I'd have to look at your code. I know you sent me some stuff. I have to look at it. This would just help you with debugging what's going on.
I haven't really done too much research, but for OpenXL, will you need a pip install, or is it an actual? Do you guys just do import?
Yes, you'll need to do a pip install for that one.
Okay, so I'll have to do that same code that you did, where it'll say like do pip install OpenXL, right?
Yep. So you can see here, you're going to have OpenXL. You'll probably need to do a pip install if it's not installed correctly.
All
Yep.
right, got
So
it.
here you can see where you can do a specific version of this. Note that this book is saying that you need to use a specific version when you install it. There are newer versions, but they may not be compatible with this information that's in this book. So if you want to use the newer version, make sure you go get the actual OpenPy docs, which are here, which will give you examples on how to do it.
Okay. Thank you.
Uh-huh. Great questions. Anybody else? Okay. So again, on Wednesday, what we will cover is everything you need to know for the final project. That way you guys can start looking at those. I am in the process of grading all your guys' midterms, so I'm getting those cranked out as quickly as I can here, but I want to give you guys good feedback. Once those are done, I will send out an announcement for everybody for that. I will get this video uploaded here. Don't forget you have a quiz. And again, on Wednesday, I'm going to cover what is all needed for the final project. You guys have access to this now, but I will show you how to go through and do this. There's also a good video out here that shows you how to convert a midterm to a final project to get your OOP requirements and stuff like that. We'll talk about that here a little bit later after we talk about OOP. But this is where you can submit your final project. Don't submit your final project, whatever you do, as it says here. I actually need to change that date. But you don't submit your final projects until you schedule your final meeting with me. And don't message me to schedule. There'll be a whole announcement that shows you how to do the scheduling. So that will come up here, and we still got plenty of time. We're only about halfway through here. But I'll go through this rubric and all that kind of stuff here on Wednesday. That'll get us through the debugging. As far as what we have left in the course, next week will be web scraping, and then the last one will be object-oriented programming. After this week, we will start scheduling time for the final project. So there'll be a couple weeks to schedule your final project. You will pick a time in there. Again, all that information I'll release later, so I'm not repeating myself. All right, I'm going to end this recording.